Welcome to the panel on sustainability of next-gen materials. I'd like to welcome Rachel Cernasky, sustainability editor at Vogue Business, who will be moderating our next panel. In addition to her work at Vogue, Rachel previously covered and still occasionally covers food and agriculture, environmental science, health and global development for other publications including Nature, Science, The Washington Post, and the New York Times. And joining Rachel will be our panelists, Ranjani Theregowda, environmental data scientist at MII, Joël Mertens, director of Higg product tools at Higg, Yuly Fuentes, future of fabrics at MIT and advisor to Closed Loop Partners, Dr. Michael Saltzberg, global business director of DuPont Materials, and Libby Sommer, director of corporate responsibility at Bolt Threads. Thank you all for joining, and I'm excited to hear this discussion. I'll pass it over to you, Rachel.
Thanks, Nicole. Yeah, I'm excited too. It's great to be here, and we have some really great speakers here. So we can get started. Yuly, let's start with you just to kick us off on a very sort of basic level. So can you tell us why next-gen materials are necessary in terms of sustainability? What issues are they being positioned to solve?
Thank you, Rachel, and thank you everyone who stayed this late in the panels. First, I would like to introduce myself. As Nicole say, I get to see both sides. One is the early stage of the idea of making a textile or a material or a molecule, to the point when now we're deploying capital and understanding, well, is that going to make a scale? So with that perspective, the necessity of these next gen materials comes from human nature. We've been making for decades, for centuries. It's in our DNA to make. And when we use materials, we've been using what is available in the resources of the time, the technologies that are available to us to make, and also within cultures. So the result of that are the products that we get to experience and to build as a society. So in that making process today, 2022, and where it's coming ahead, we're in a really completely different space on what are the technologies that are available for us to make these new materials. How are we thinking and quantifying? And I think this is a lot of what we're going to discuss today on how do we account for material A from material B, apples and pears, right? And without that quantification, how can we make progress? If you don't quantify, you don't know if you have something good or bad. Or not even that, how can you improve for better performance? So the necessity of that next generation of materials comes with the need of keeping evolving. How do we live? And now for a new client, we've been humanly centric developing products, but now we got the aha moment that we have a second client, which is planet Earth. And without planet, we humans cannot keep living here. So it's an exciting time I'm a technologist, so I'm optimistic. And I think that with the people that is here also in the panel, we can really kind of think in a future that is even better and not just replaceable.
Yeah, okay. Thanks for that. And I forgot to, I was so excited to just get started.
Yeah.
I wanted to invite, this should be a sort of natural conversation. So if anyone has points to add, please jump in. Joël, I know that you have talked about the sort of innovation gap. Do you want to add some thoughts there?
Sure. Yeah, I think one of the things that certainly, of course, climate is one of the forefront issues of the times. It's not the only issue. There's many coexisting issues that we have to solve for. But with climate, one of the great things is that there is a bunch of resources out there for industry that's trying to figure out, well, what can we do? And there's a report that WRI and AII published for the apparel industry about, what are some of the key interventions that will help us reduce our carbon emissions on a path that is consistent with what the science is telling us, and getting a 45% reduction in the next 8 years. And what's really interesting is they highlight 6 interventions that can be achieved, and then there's this innovation gap. There's like roughly 2/3 of the impact reduction can probably be accomplished by things that we already know in terms of like switching out coal in our supply chain, using more renewable energy, increasing material efficiency. And then there's this like innovation gap of saying, well, that gets us part of the way there, but actually to get to what we need, we have to change the paradigm of how we're thinking about things. And I think this is really where the next gen materials can really play into things is to say, okay, well, that's part of that paradigm shift of what do next gen materials bring to the table.
Great. Okay. And I also realized, because I just jump into questions all the time, but I did also forget to have everyone sort of introduce themselves. So if we can rewind and then we'll come back to where we're leaving off now. But I should have everyone introduce themselves. So I'm sorry, I'm being a terrible moderator. Libby, can we start with you? You're muted.
Yeah, I'd be happy to introduce myself. Hi, everyone. I'm Libby Sommer. I'm Director of Corporate Responsibility at Bolt Threads. I wanted to introduce myself and then also introduce Bolt Threads, if you're not already familiar with Bolt. I've spent my career, which is getting close to 20 years now, focused on the central question of how do we design products better from the very beginning. I started my career at the Environmental Protection Agency, working with lots of different industries on green chemistry and adopting green chemistry into their products. In my time there, I saw other companies making fairly costly mistakes, sometimes to the tune of $40 million, by not using sustainability materials up front in the design of their products. And what was especially unfortunate about those mistakes is that they were easily predictable, using tools that we've developed in the sustainability world to understand impact and to predict what that impact could look like. I've spent my career throughout EPA and also at Nike and Lululemon and now at Bolt Threads, trying to understand these sustainability tools like green chemistry, life cycle assessment, health and safety, social responsibility, materials testing, et cetera, and applying them in products in various industries. I've been most compelled by the apparel industry of all the industries that I have worked with, because there's been generally this open and inviting sort of sense of we want to change, we want to do better, we want to improve these products and their impacts. After working at Nike and Lululemon, I ended up joining Bolt Threads about 3 years ago because I saw this immediate alignment between my interest in designing for sustainability from the very beginning and Bolt's mission of way better materials for a way better world. And at Bolt, we've been focused on bringing to life a leather alternative made from mycelium. We call it Milo. We're doing this because brands and consumers are demanding solutions to some of the sustainability issues that various types of leather can bring. And those issues can include life cycle impacts, carbon footprint, water footprint, hazardous chemistry, deforestation in some regions of the world, labor concerns, et cetera. So we designed and developed Milo using a 6-point framework that includes preferred chemistry, life cycle assessment, social responsibility, facilities environmental responsibility, traceability, and supporting circularity. And we're currently working with Adidas, Lululemon, Kering, and Stella McCartney to commercialize the first products of Milo. Lululemon offered 2 bags for public sale earlier this year, made partly with Milo. And Stella McCartney will launch the first product made primarily with Milo later this year. I'm really delighted to be part of this panel. Thank you so much for the invitation, Nicole and MII, and I'll turn it over to the next person.
We'll just go in the order of my screen. So Mike, you're up next.
Thanks, Rachel. Yeah, my name's Mike Saltzberg. I lead DuPont's biomaterials business. Basically, my background is as a material scientist. I come at this from somebody that has always been interested in bringing new materials to the world that have better performance and better sustainability. I've done a lot of different jobs at DuPont, but for about the last 16 years, I've been leading this biomaterials business. And when we say biomaterials, what we mean is products that are made from renewable resources, plant-based resources, rather than from petroleum and natural gas, like a lot of the petro-based plastics that are out there. So I think one of the things that sets our business apart is we've been commercial now for almost 16 years. We're about a $300 million business. We make a couple of different products that go into a variety of industries. One of them is called Corona. It's a polymer that gets spun into fibers that are made into Mohawk Industries Smart Strand carpet. And also, as Libby was mentioning, in the apparel industry, we're very big in the apparel industry with our products. And we also make a chemical called BioPDO. It comes in 2 flavors, Zemea and Cistera. And those 2 products go into the personal care and cosmetics business, where they replace things like, petroleum-based ingredients in hand creams and cleansers and all kinds of consumer products, or they're used in industrial products to replace, again, petroleum-based intermediates. And I think one of the most important things that we'll talk about more on this panel is being renewable is great, but what really matters is that you've got to look at the whole picture and make sure that if you're going to replace one material with another material, that it's actually better for the environment. And so I think taking a holistic approach, measuring things the right way, there's a lot of great folks on this panel that know a lot about that. And that's a big part of what we do, is to make sure that we help. We're a material supplier. We sit way back in the value chain. So we help all of the folks in front of us that eventually get products to consumers to run their processes using materials that have less of an impact on the environment, whether it's the way they're made or the way they're used. And so that's a big part of what we do at DuPont Biomaterials. So thanks, Rachel. I'll turn it back to you.
Great. Thanks, Mike. Yuly, you're to Mike's right. So please introduce yourself.
Yeah, I did the quick one in the ideas and in the investment. So a little bit of myself and how I am excited about this panel. My background is technology. So my PhD once upon a time was in neuroscience. So I'm really versed in understanding systems. And I think materials are part of a system, which is something that we always have to keep in mind. Then I specialize in the economy of innovation. So how do you create value out of new ideas that are coming out from economies that are creating a new centric, right? So we are now in the cybersecurity. What is going to be that? And materials are being an industry that has evolved over time for so many times. So how do you measure that? How do you think about them? And how do you create value and markets that are going to do that? So that's kind of how I see the world. From the point of view of what I do, I'm really passionate about the younger generation that is going to take this and keep going. The material scientists of the future have a completely different challenge than the ones that were at my time in the lab. And with that, in MIT, I dedicate a lot of my time in re-understanding what is going to be the workforce and what tools are we giving to the young scientists to really rethink the world that they want to live in. And in the investment side, we work in Closed Loop Partner. Closed Loop Partners is a firm, is an investment firm that has a platform of investment vehicles where we deploy capital with the intention to really overcome the challenges of circular economy. This firm also has an innovation center. I sit advising most of what it has to be with the investment firm. And we're really dedicated agnostically on different stages of companies in how can we help them to scale up for the next phase when they need capital to empower the circular economy. So that's me.
Great. Thank you for that. Joël?
Hi, everyone. So I'm Joël, and I work at the Sustainable Apparel Coalition on the Higg product tools. So Sustainable Apparel Coalition has developed a suite of tools that looks at trying to measure and standardize performance sustainability performance across the industry, whether we're looking at how a brand has, how it acts basically with its supply chain, its processes, the way it tackles its risks, whether we look at facilities and how they're managing their environmental and social impacts, or the area that I'm most involved in, which is the product impacts, how you design and develop a product and convert it into from the ideation phase through to actual on the shelf and ready for consumers. And I've been at SAC for about 2.5 years, and before that I was at a brand, and one of the really interesting things that stood out to me as I was in this in the design team, basically embedded in the design team, looking at different elements of sustainability, is that it really does help to ensure that there's a common frame of reference, and as well as a holistic frame of reference. It was really interesting sometimes where KPIs would look, so key performance indicators, look really good on paper of like how we're going to measure something. We're going to track, the amount of recycled content that we're using, and you see it going up and you're happy. And then you take a step back and like look at the full picture of like, well, out of the overall production that we have, yes, recycled's been going up, but conventional products been going up even faster. So there's all these interrelated pieces, and how we look at them both at an individual level and as an industry. It's really going to be, how do we unlock those learnings as an industry as a whole to really drive things forward. I think one last little kind of fun tidbit, I guess, is before I got into the apparel space, I never really saw myself in the apparel space. It was, not something that's really highlighted often in other than maybe the design element, but on the science side, certainly not really highlighted in most North American universities. And I was working basically with material innovation for the renewable energy sector, and kind of building nanoscale fibrous materials, and that kind of then translated into an opportunity within the apparel space. And it's been fascinating to kind of see the impact and desire for change, I think, but also the challenges in getting there. So yeah, really excited to be part of this panel.
Great, thank you. And
yeah. Hi, I'm Ranjani. I'm a part of MII, and I'm really happy to see you all here. And to say I'm the environmental data scientist at MII, and I've been highly inspired to join MII. Joined in January, but then even before that, I've been inspired with the next gen material innovation that's going on. And so my passion towards learning more about that and applying LCA was what drove me to become the environmental data scientist here. And I really am inspired by MII's work, because they're not only animal cruelty free, but they also encourage next gen material industry to adopt sustainability at the early stage of even design. And as a part of MII's scientific department here, my main focus would be to help consolidate and make environmental impact data related to textiles more accessible, consistent, and reliable for all stakeholders, regardless whether they're an innovator, brand. We try to connect the pieces because especially sustainability evaluation is not very easy, as we all know, and that's why we are here today to discuss that further. And so I think MII's vision to bring forth everyone to share their concerns towards sustainability evaluations is really inspiring. And also my experience is basically in LCA approach, application of LCA. I've been in this field for about 10 years now, 10 plus, and also applying sustainability metrics. And I've applied it for diverse areas such as leather, bioleather, and then natural rubber tires, even wastewater treatment, and traditional fertilizers. So LCA approach remains similar, but the products or processes they're applied to are very different. And so it's important we discuss before doing an evaluation whether we're all doing it consistently and reliably and even transparently. And I think that is very important today in our discussion. And I thank you all again.
Yeah.
That's me.
Yeah, great. Thank you. Clearly the LCA and the sort of contextual evaluation of a sustainable, of the sustainability of material is going to be a big theme here. So great. Okay, so now we can go back to the discussion. Libby, can you talk about what types of materials present the most urgent need for next gen replacements?
Yeah, I want to start with some of the issues that are present when we're talking about materials and sustainability. And you can talk to a given brand in this industry, and they will have a different take on that. Some brands think that we need no animal products. Some brands think that we need to optimize for low carbon footprint. Some brands are trying to address deforestation. Some brands want to bring manufacturing closer to shore, more domestic production. These are all reasonable and principled stances for a brand to take. None of those is necessarily wrong. One of the materials that gets implicated in a lot of these issues is, of course, cow leather. And so you've seen a lot of discussion about leather alternatives at this conference, in part for that reason. There's no material replacement, including next-gen materials, that will solve for every single one of those sustainability issues. But if we design materials better from the beginning and manufacture them deliberately and intentionally to address especially those key hotspots, next-gen materials can provide a really compelling alternative to materials like leather that do carry some of these issues.
Great. Okay. Great. Joël, can you talk about how do you conduct a life cycle assessment of a new material, and our current LCA, and for anyone who hasn't picked up, LCA is life cycle assessment. Are current methodologies adequate? And really one specific sort of area of oversight, I think, is sort of avoiding unintended consequences. So are there strategies or best practices for avoiding those?
Yeah. LCA is certainly it is one of the tools that exists in the kind of repertoire of tools of trying to understand and manage impact. And some things are really well described by LCA, and other things aren't. So if we look at something like greenhouse gas footprint, the methodology to calculate greenhouse gas footprint using LCA is fairly well understood, right? Basically, it's leveraging the decades now of climate science that's been done to understand what's the equivalent footprint of different emissions that can end up in the air. How should that be taken into account? Even with that said, I'm going to take a step back and say, while that part is well defined, there's still different ways you can treat within an LCA study different emissions, whether it's a 20-year time frame, a 100-year time frame, how biogenic carbon gets accounted for, so the carbon that's absorbed by plants, when it's considered sequestered or not. So there's even within something that's as well defined as climate change indicators, there's still a lot of flexibility, and that's where trying to standardize approaches becomes really important to be able to ensure, while you do have in many cases apples, pears, oranges, and things, how if I have two varieties of apples, I'm actually looking at them the same way. I haven't made different assumptions in each of those assessments that are going to lead to incomplete or incorrect decisions. Really, the fundamental framework of LCA is very standard across any industry. Really, you're looking at what are the material inputs, what are the energy inputs, what are the waste products out, and how does that all fit together. Of course, to do that, really, when we're looking at a full cradle to grave footprint, there's many things that you're not going to know or have the direct ability to collect primary information on. So if we think of something like using a plastic material, polyester or whatever it is, okay, well, to make polyester, I know that I need to have certain monomer inputs for that polymer. Well, to make those monomers, I need to have other oil and gas inputs at a refinery. Well, in order to get that, of course, I have to extract it from the ground. Same with something like a natural fiber. I might know that I'm using cotton fiber, that I'm using corn or whatever it is, but all the upstage processes of saying, well, how is that fertilizer made? Where is it made? There's going to always be areas where assumptions have to be brought in. And this is where there's so many different ways that this can be done, that looking to kind of standardize approaches becomes helpful. And one of the ones that I know we use with the Higg product tools is the product environmental footprint project in Europe, where they're trying to kind of leverage their academic community to say, like, how how should you allocate cow leather? How should you look at the hair from a sheep? Is it, how do you allocate the different impacts across different industries, across different products, and try to bring some standardization to that? So that's something that then we internalize, and to really bring LCA, I think, into the scaled stage, because of course I'm just talking about all the reasons that you can do LCA, but how it's complicated and hard, really to bring it to that next level. And one of the things that we're really trying to work on more and more is turning it into a simplified on the surface. What are the inputs you need to provide to then get to the LCA outputs in a consistent way? Next gen materials are a little more challenging in this context because, of course, each has a slightly different production method. So trying to find it's not going to be a simple single survey of saying, okay, well, I need to know how much, corn you're using. Well, some people might be using corn, some people might be using something completely different. There's going to be that need to say, we're never going to have, there's always going to be criticisms of like apples to apples because no two materials are made exactly alike. But as long as the process flow is followed, you can get to a pretty consistent outcome. And the last point that I'll say is, again, back to my initial point, LCA is one of the tools here. It does certain things well. It does certain things very poorly. And that's where you have other kind of needs to use other sort of management assessments, whether it's something like animal welfare, whether it's something like chemicals. Maybe you can get directional indicators of risk, but really to understand how you're going to manage that risk point requires focus outside of what an LCA can tell you.
Rachel, if I could jump in and add something to what Joël said, because he does such a good job of talking about the challenges and cautions around applying life cycle assessment retrospectively to something that already exists. In this conference, we're talking about materials that in some ways don't yet exist. And so we're applying life cycle assessment prospectively to understand the potential impact of these materials. It's a really important thing to do, but it comes with some unique challenges that aren't present with the retrospective application to materials that are already in production. And there's a really good paper that I'll share in the chat with this group by a professor at the University of Calgary. Joël Burgesson is a life cycle assessment expert. And she talks about the challenges of applying LCA to an emerging technology in a mature market. And she says there's really two kind of key situations. The first is you don't yet have a production process. And so you make assumptions about what that production process can look like, and they can be overly optimistic. The other situation is you get more reasonable assumptions, but then you're trying to compare to an existing material that's well optimized, that has decades, maybe even centuries in some cases of optimization. So you're comparing an emerging technology to an incumbent technology that's very well optimized. So how do you rationalize those two things? I think those are important things for brands, especially to think about. We've gotten the question all the time, what is your footprint? And I think what I'd rather brands ask is, how are you using life cycle assessment to inform the way that you're designing and developing this material? What are the things that you're doing to drive down that impact? I think at this stage, that's actually the best use of life cycle assessment.
Rachel, if I could add something here.
Please do.
So coming to next gen materials and LCA, it is very true what Libby said, but there are levels in LCA as such, like a conceptual LCA or something called hotspot analysis. And I feel LCA best fits in when you are in the design phase and you want to improve your product rather than compare it to different products. And that point of time, a hotspot analysis would basically include only the data you try to have for your process, and try not to use as much secondary data as possible. But at times, like Joël said, we would have to use secondary data, and that's where a lot of uncertainty, and it would help to have scenarios in those cases. And still, LCA is still very sort of a naive tool for next gen material itself. Next gen material itself is naive, and on top of that, LCA would more be a developmental tool with the iterative approach of going back and forth and expanding your system boundary or decreasing it. And the other thing is there are other kinds of analysis that could be done, like techno-economic material flow analysis. And I would like to put it out there for next-gen industries to at least start with those, if not with a full LCA, because LCA, like Libby said, it's after you've come to a certain stage of development wherein you have information enough to analyze your process. So I think LCA has its applications, but it would still be a lot of uncertainty involved in it.
One point that Libby, that you made that I want to just have anyone sort of comment on, that point about not measuring or asking the carbon footprint, but how are you using the LCA? How do I phrase this? I mean, one sort of issue that I see often is numbers are given in a vacuum, right? Like a company is reducing its emissions by such and such amount without any sense of how many is there, how much are you generating total, or water. There's a bit of an echo. Sorry. How much water are you saving, but how much are you still using? And so there's often sort of a focus on the effort and not necessarily on what sort of needs to happen from a planetary scientific perspective. So I just wondered if you could elaborate on that point that you made in the context of the need to focus on on the sort of absolute in a way, if that makes sense.
Can I jump in here? See if I can add a different perspective. So, in the end, this is all super complicated, like everybody's saying, but in the end, decisions have to be made, right? So if you're a brand that has to make a choice on, I'm going to make this shoe top out of nylon, or I'm going to make it out of, Sorona, how do I make a decision, right? And so I think as much as it's absolutely evolving, it is all those things are true. Decisions still have to be made. And so typically what I see happening in the industry is there are some absolutes, Rachel, like you're getting at. So for example, greenhouse gas emissions, as Joël mentioned, is one that's pretty well sort of, people sort of agree on the methodology. If you do a refereed life cycle analysis, you do a non-greenwashing, true, authentic life cycle analysis, which a lot of companies are doing now, and you get it refereed by real experts. Greenhouse gas emissions or non-renewable energy are things that people can look at. So there are some areas where you can really get like, hey, this particular material has less greenhouse gas emissions than this particular material, or this process has less than this process. So there are those things. And I think the other ones, we're still trying to figure out, and again, it depends a little bit on what's important to that particular brand, exactly how to do it. I personally don't find that companies coming out and talking about how they're this much better than they used to be, that may be of interest to their shareholders, but it doesn't really help society or people downstream much. We've got to focus on being really transparent, really authentic, really credible data that's refereed by sort of third-party credible scientists, and then focusing on a few metrics at this point that we can all agree on. I think that's a way to move forward. We'll get better at this as everybody learns more about it. But for where we are now, there's a few things we can all focus on. And I see that's where people are moving forward. We work with tons and tons of brands and have for many years. And it's sort of some things are coming to a consensus. And those are the ones that we tend to focus most on. The other area we haven't really talked about is plastics pollution. What I see right now is there's the two really big things are climate impact and what are you doing about, how are you contributing or not contributing to plastics pollution? Those are really the two on top of mind of most brands I talk to.
Yeah. Okay. Well, and unless you wanted to jump in, I was Mike. The next question. Yeah.
I can say something. I while listening to all of you, I was reflecting on a natural behavior, which is we're paying taxes. Every other one of us is paying taxes, and we hope that transaction or that accountability has been done right. And every country has their own way of measuring taxes, but there is an invisible process that say, okay, I don't know your taxes, my taxes, right? So we're going from that type of management of data to something that we want to know why, in what use, in one context. And also I will add in a dynamic context, because one product, you change one thing and then you're changing other things. So we have to have the technology and the tools to respond to that in order to give answers. The second is audience. So when I'm assessing a company for investment, I'm looking for their, of course, impact data. And it's different from if that impact data is going and given to a specific brand, because that brand is going to particularly create a particular product. So audience and how do you communicate that, and trust building is really important.
Mm-hmm. So on that note about trust building, and also probably building a little bit on the plastics, but maybe not. Mike, back to you. And I want to make sure that we can get through all of our questions to leave time for audience questions too. But Mike, how do you convey all of this information in an accurate and reliable and digestible way?
Yeah, so I think we sort of already touched on this to some extent. Obviously, again, it's super important to be transparent and authentic, right? So there's a lot of people out now that are just throwing the word sustainable around to try to sell products, and that doesn't help anybody, right? So the first thing is you've got to be data-based, you've got to be transparent, sharing as much as you can about how your product is made. Some things are proprietary, right? Of course, but we've got to be able to do that. And then I think it's also about taking this complex data and using really smart people to take all that and make it simpler. Telling people how complicated things are doesn't help anybody. It just doesn't. So if we can come in and we can begin to talk about how, for example, our product's based on corn. And so it's very important not only to talk about the process that we use in our factory, but also to talk about how are we working with farmers to ensure that we're sustainably sourcing that corn, because that really matters. And if somebody's going to compare, for example, I don't know, PET polyester to our product, which we often get compared with in certain applications, they're going to want to know all the way back to that farmer, how much impact was there on the earth to grow the corn that you used, to do the fermentation, to get your chemical, versus the guy that went out and poked a hole in the ground and pumped, petroleum up out of the ground, and how do we compare those things? So I think, first of all, again, transparency, authenticity, and credibility in terms of using third-party sources, all those are really important. And then breaking it down into a few key metrics and then sharing as much as you can about the whole process so people can see that tends to matter. Different audiences care about different things, like a lot of folks have already said in this panel. So what we're typically looking at is there's a consumer kind of a way you want to message this, and that usually is the way brands think about it. And there's also people in our value chain. We sell materials that people make into fibers, and they make those things into fabrics. All those people also worry about their sustainability. So sometimes we have to talk about different aspects with those people than we do, let's say, with consumers. So I mean, that's a lot of different stuff, but I do think this is one of the biggest challenges, right? Is we're kind of past the point where we're thinking, wouldn't it be great to have new materials? New materials are out there. We've been out there for 15 years. We're hearing about a lot of great new materials in this conference. We've got to get to the point where we can communicate these messages clearly to people in a way that they can understand it.
Right. Yeah, that's really important. Also important is end of life. So Yuly, can you talk about how you plan for a responsible end of life for a new material?
Yeah, I think especially for circularity has been out there with the idea of bringing back resources and reuse it. And I was taking the point when people say, okay, don't use petroleum-based materials, but nobody explained why. So the energy that takes to take materials from the ore is huge. That's the simple explanation. And polymers are polymers, and we're taking them from different sources, and they are being polymers, and we can use the same chemistry and now learn to kind of how to separate that and how to make it available for other industry. End of life is super important for the idea that we can keep using materials in the same space with same stream, but we need to think about how that material is going to have different prices in different end markets, and how the material can be better. We're now not making materials for replacement. We're making materials for better performance, better things, better products. So when you optimize for that, end of life became challenging. So designing in that mindset also is important. Are you designing for the end of life of that particular product.
Mhm. Right. Okay. And again, if anyone wants to jump in, please do.
Yeah, actually, maybe I'll jump in on this one because I think this is actually a great area to talk about how data can be used or misused. Because if we talk about something like mechanical recycling that is ultimately it's still recycling, but it's not really closing the loop in the same way that a chemical recycling process could do for polymers in this case. It's interesting that of course it's going to take more energy to regenerate something back to the monomer level and right back into like a first quality good than it is to take a waste from another industry, grind it up and melt it down into a mechanically recycled substrate that is still good, but it's ultimately it's a degradation of what it was before. And if we look just at the data and say like, well, what's the carbon footprint of mechanically recycled versus a chemically recycled process, you can say, wow, mechanically recycled has a lower footprint than chemically recycled. Okay, but it hasn't solved the problem that we're trying to solve. And I think that's where it's important with whether it's LCA or really any other metric to know what you're trying to solve for and be able to recognize where sometimes there are going to be trade-offs and that's where that design iteration that Ranjani and Mike and Libby were talking about of saying like, we have to know where our impacts are, where we still have big impacts. Okay, maybe I've moved from a petroleum-based material to a renewable material, and okay, the water footprint's gone up. That's okay as long as you've said, what's the problem I'm trying to solve? It's the fact I'm using a non-renewable resource, and I want to switch to something that is, renewable, that can exist in a closed-loop system. Great. Now I'm going to have questions to ask about what you're doing to improve your water footprint. And that goes back to kind of Mike's point around how they work with the farmers to be able to say, well, what are you doing to have the most sustainable corn in your process possible? There's always that level of improvement that we need to layer in here. It's not just about the footprint. It's about the ongoing conversation to know what you're trying to solve for, how you've solved for that, what's the next issue that needs to be solved for, and how you're going to work on that one.
Mm-hmm. I'd like to talk about scalability more. We've touched on it a little bit, but how can all of this apply to the industry at scale and to have the impact that is needed? Mike?
Yeah, so I think first of all, it's absolutely crucial if we're talking about new materials making an impact. They can't just be little niche products for super rich people, right? So we work with all the different kinds of brands. So we've had some great success with people like Stella McCartney and high-end fashion, fantastic stuff, really great. But what excites me about those is that typically it inspires more mass market brands to start looking at new materials, because that's what we need to do, right? If we really want to make an impact, we've got to be talking about reaching price points and performance levels. Yuly made a really great point that performance really matters, right? So if we come up and we invent a whole bunch of really sustainable biomaterials that are really got a great Higg index and great LCAs, and they don't perform, no one's going to buy them. So the challenge for all of us is that we absolutely have to bring out high performance materials that meet the consumer needs. And we have to be able to do it at a price point that they can afford. And so scale is really the critical thing. And one of the real challenges in the materials industry, which is different than, for example, if you're doing something in the software industry or the pharmaceutical industry, is it's a really big and long and deep, what they call valley of death, right? So if you start off in a lab and you invent a really cool material, you don't get paid until you've built a factory and you've commercialized the product, and a whole bunch of people downstream have adopted that material and learned how to use it in their process. And if it's a new material, not just a drop in, they've got to learn all this stuff about how to apply it. So it takes a really long time to get paid. And so that's really a challenge in the industries we're talking about, but we have to solve it, right? We have to find a way to do it. So I was lucky enough, I work for a really big company. And so DuPont started working on some of the products that are commercial today in the 1990s. And we had the luxury of time and patient capital to get these things through. A lot of the amazing innovators that are out there today doing incredible work in the startup universe, the big challenge they face is even if they are smart enough and lucky enough to solve the problem and they got this amazing material, surviving that valley of death, getting that plant built, getting everybody to take that material and commit to use it so they can get funding, all that stuff is a big problem. So I think it's something that doesn't often get talked about. We love to talk about the technology part. The money part really, really matters. And so we've got to figure out ways that there are partnerships. So for example, brands control the demand. They need to work with us backward in the value chain, those of us in the material space, especially startups that don't have a big parent like I do, to guarantee demand and help them get financing and all that kind of stuff if you want things to change. Otherwise, we'll just keep talking about all these great ideas on the one side and these big problems on the other side, and there'll be this big valley in between that we'll never get across.
Are there?
Yeah, I want to add something. I share the enthusiasm. So in my hat of investment, one of the vehicles I have the pleasure to help support and build, and it's going to be public end of the year or so, it's exactly that point. It's in a scale up where companies go to the valley of death. So how can you design financial instruments that help companies to pass that valley of death? Because in a time, if you're thinking as a purely investor, that's an economical opportunity, right? The return is going to come back if you design financial instruments for the scale. And I think before what was happening is that we have few companies kind of evolving this pipeline of opportunities for next gen materials, but now we have a universe. And I think we are in that point when we can bring the financial tools to kind of fulfill the skill for what has to happen for the next stage. Because it's true, the challenge of material compared to software is that we need to go to the factory. We need to touch and play and make the product. And that's completely different than be sitting in a computer and playing with code for a whole afternoon, which is okay, but we cannot design the financial instruments for the software company in the same way we do it for the material companies.
Right. Yeah, and just to add on, I mean, I think if you think about, a lot of folks are coming to this from the biotech world and the biotech medical world. If you design a really cool therapy, a drug, whatever it may be, and you get through, let's say, phase 1 trials, and you can show that data, you get paid. That doesn't work in that way in materials. Nobody believes you until, as Yuly just said, the factory's built and 27 people have adopted it and their products are commercial. So that's a real issue that we got to think about. And what I am really excited about is I am seeing the financial folks really trying to do this. There's a lot of funds out there that now are sort of talking about balancing off. I got to make all my money this week, like the typical private equity guys, and trying to do something good for the world and having that kind of patient capital. That's what it's going to take.
Okay. Libby, did you?
I do want to add one small thing, and this might sound a little bit surprising coming from someone like me who's been in the sustainability world for all my career. But sometimes it seems like the pendulum has swung too far to the side of, the questions are first about sustainability, and then second about whether that material even works or is durable or is desirable. And, you hear like, our footprint is this, or this material is 100% that. But what about whether there's demand for that material, whether brands want to use it? And we certainly don't want to be in a place where we have a low carbon footprint material that gets adopted into products, and then consumers don't purchase that product and it ends up going to the landfill because no one likes that material. That context of the whole system is so critical to actually leading to the sustainability change that we want to see.
Right. Yeah, and it's such a sort of ecosystem, the problems that the industry faces and the solutions that are needed. Well, one more question for the panel before we go to the audience questions. Ranjani, can you talk about, just looking ahead, what are some key future research needs, and are those where the main gaps are, or what else is needed before we can start to see, the industry adopt these materials at scale?
Yeah, thank you. Actually, that itself, like all of this discussion right now that was happening, was about like how to make it viable and sustainable and performing and everything together, right? So that itself is complex, and the process of designing itself requires a lot of research. And on top of that, you have sustainability to carry or other expectations from the industry. And so to build that process, there are a lot of white spaces there existing, and that requires a lot of research. And to do that research, we need technical experts or experts who are knowledgeable in that area. And I feel that right now, just to train people and to make them understand what we are exactly looking for in the future, and also to discuss the issues surrounding this whole point of sustainability, along with performance and building a new material or next-gen material. All of this requires a lot of collaboration. Like throughout this day, we've been hearing from all experts. And I feel that to bring that about, MII is actually trying to launch something like an environmental data coalition. And what this coalition is planning to do is that we bring together brands, stakeholders, innovators, to discuss their issues regarding sustainability and do further research on that and do targeted work related to that. And I feel some of the issues there to address is that the process itself, like identifying what are the common issues faced by all of these industries, and to do persistent and impact analysis within the next generation industry, next gen material industry, and also bringing these issues to light, at least discussing about them, even if we can't find a strategic solution right now or tomorrow. All this is critical, and I feel that right now, EDC, the Environmental Data Coalition, is something that is required in this area, and we request everyone whoever is interested in learning about this further research to contact us at the team MII, or even write to us. And also, one thing I really would like to point out is these issues are also discussed in White Space report that MII has published a year ago, and also reducing subjectivity in terms of performing LCA or any sustainability analysis is something that needs to be looked into in future too.
Mm-hmm. Okay, great. Great. Well, I think that kind of touches on one question that's here from the audience. So I guess I'll work backwards because it's interesting. There's one here from Tiffany saying that there are, as we all can see, that it's come up that that there's a lack of talent in the apparel and biotech and textile engineering space. Does anyone have any comments on that?
I can take that from my MIT hat. It's true. What we've been training for is the pure engineer or the pure biologist and the pure designer. And the efforts that we need to start doing is to create this hybrid mind people, the ones that can have the language to interact with the supply chain across, and they have kind of the empathy, and I use the word empathy, big letters, to really put themselves in the shoes of every single persona that is going to touch and evaluate that material. Some work that I personally have been doing, for example, back in 10 years ago, it was put in the same room the fashion designer with the scientist from the lab. That conversation is fascinating. And in the moment they understand that they're in the same mindset, is where you start kind of building new curriculum for the new generation of people that is going to be in charge of this industry.
Mm-hmm. Yeah, I think it's a great point. Yeah. Okay, next question. The Higg tool is great, and this one, it looks like, is directed to Joël. The Higg tool is great for communicating with brands and supporting their directional choices, but how are you thinking about using the tool to provide useful guidance and insights for innovators?
Yeah, this is a great question, and there's kind of two levels, I think, 3 levels, depending how you want to look at it. Really, the Higg tools as they are today are intended to be used by the designers, developers of an apparel, brand or a manufacturer, within the context of especially the textile supply chain. So there's other aspects that are layered in there, because of course to create a product is more than just textiles. But a lot of the impact is related to the design choices that are happening in the tier 3, tier 2, and tier 1 space, which is kind of the apparel cut and sew, the textile wet finishing, and the way you spin your yarns and make your textile materials. So if I'm looking at textiles, a lot of the impact actually is, raw materials is important, and that's certainly part of it, but also the conversion from raw materials to finished textile, or if we're looking at other materials, the actual processing so much. The processing is going to be the important part. And that's where I think as we get into new innovation, especially where, you kind of merge the layers of supply chain together, that's where we haven't been a strong supporter of providing insights back to innovators like that are making a lot of the materials that are covered at the conference, to be able to say, well, if I have a combined process that's doing everything from tier 4 to tier 2, and I have my material kind of going directly into a garment factory, I want to be able to see the same type of impacts that I can make that a material developer doing textiles can see with the tools. So being able to see, like, okay, if I'm doing textiles, what's the difference of different dye technologies, or what's the difference of different yarn spinning techniques? What does that mean in the context of other material innovation? And that's something that really I think has to be a partnership of looking at how we break down the processing choices that innovators have, and trying to provide more visibility into what the trade-offs of different processing choices are. There's also, I think, a deeper layer of like just hotspot analysis that ultimately is going to be fulfilled well by existing LCA consultants, and that role of, when you're kind of first ideating at a new material level, new raw material level here, especially, there's going to be aspects that are fundamentally going to be unique to your process, that having a tailored LCA is really going to provide the insights into what your specific hotspots are going to be.
Yeah. Okay. Let's try and sort of power through the last few to hopefully get to all of them. This one is for Libby. Will there need to be a large increase in a variety of crops to sustain a demand for bio-based materials? And should investments be made in soil regeneration, as deforestation is not only done to accommodate cows, but also when soil can no longer sustain crops, if that's true? And then a really interesting question: does mycelium help improve soil that has been drained of nutrients?
Yeah, there's a lot of good questions in there, Jennifer. One thing I want to say to start off is that just in the U.S. alone, about 90 million acres of land are planted with grain and other crops, and roughly 95% of that is used for animal feed. So if we rethink where these resources are going, and think about more efficient use of those resources, I think there's a lot to be gained from the entire system. That's not something that one single innovator can address. It's probably not something that even this industry alone can address. But I think it points to the bigger view that you're talking about of this whole system, and how are these things connected? How is deforestation, soil regeneration, and the use of these crops connected? The vast majority of cattle production is not done in a regenerative way. And that may be part of the solution, but it's probably not the entire solution. So there's a lot to think about there. Mycelium, it has many benefits. I don't know if I could say specifically that it helps improve soil drained of nutrients. It probably does. I think we're still learning about all of the amazing things that mycelium can do and do in the natural environment. And they're everywhere. It's a super connector between plants and trees and other organisms in a forest. That brings nutrients back to trees, helps biodegrade things that aren't otherwise available to other organisms. Mycelium is pretty amazing stuff. Hopefully that answers your question, at least in part.
Great. Okay. And let's see what's left. Ranjani, can you talk more about MFA and its utility as an alternative to LCA, and maybe also define what MFA is?
Yeah. So material flow analysis is not an alternative to LCA exactly, but it could be at the conceptual level to eliminate materials that you already think are unsustainable. Like you could track the material through the process and see to what extent that material is being used, and is there a substitute or an alternate that you can use for that material. And it also tracks the amount of energy or water flow or things that could actually reduce your footprint even before you go in production. And so material flow analysis is sort of done at the conceptual level when you have very little data to do a LCA analysis, a streamlined LCA analysis. And I feel that because a lot of next-gen materials don't have enough data, and that's the problem doing LCAs. And at that stage, definitely material flow analysis, something that is related to industrial ecology studies, you can do that to the material in the initial stages.
Mm-hmm. Okay. Great. And I'm just not doing any follow-up because we're out of time. So just very quickly, if anyone wants to take either of these last, or I guess the one about emissions. So is there any risk of overlapping or overstating emissions? So one company's scope 3 emissions or someone else's scope 1 and 2. Is there risk of double counting?
I can speak really quickly to this one because it's some of the work that we're looking at is how to do an industry baseline that actually is able to be updated, that minimizes the risk of double counting. And part of it is, again, how you set up your system flow of what you're measuring. If you're tracking everybody's scope 3 and subtracting that from other people's scope 1 and 2, absolutely you're going to have double counting. If you're looking at it from perspective where I take all the unit processes of what happens and I look at what's happening across the industry of materials used, etc. In some cases you're maybe not quite as able to show the exact reductions, but you're able to minimize the likelihood of double counting. So there are ways that double counting can be prevalent, I think. There's also ways to kind of minimize that if we're looking at an industry footprint. The reality is, if we get down to it, we haven't even peaked our emissions yet. So double counting, I think, is the least of our worries. I think that there's a lot of work to actually just get into the action phase and make stuff happen.
Okay. Great. We are out of time, so I'm going to stop asking questions. But this was really great. So thanks everyone for being here. Thanks, Nicole, for having me be here.
Thank you so much. And I feel like most of our panels, we could probably have this discussion all day. I think there's so much we can learn from all of you. I really appreciate everyone bringing their expertise to the audience. And I know people are really going to appreciate it. So we have one more panel left. We are going to need to take the 30-second break for the recording, but then we'll be back for just 1/2 hour. And like Libby said, I think it's really important to know what consumers want. We don't want to bring products to market that they don't. And this last session of the day is talking about exactly that. What do consumers want with next-gen materials? See you soon.